is Pallavi Desai, and I'm going to show you my lab 4 assignment work. The lab 4 assignment work, the first model is CNN model. We have to implement with a new data set. And later we have to implement the RNN, and we have to compare this RNN and CNN model here. And we have to implement the image classification with CNN model. This is the list of work we have, and I'll show what I have done. I have implemented the CNN model. First I have imported all the libraries. Then here the dataset I am using is spam.csv. Spam.csv here is, it contains either two classes, spam, ham. Either the mail is spam, if it is not, it's called ham, and it contains the contents. It go until point, crazy, available only in big word buffet. And if it's there, it's not a spam. Ham. And if it's free entry in 2 days, if you have 150 million lakh, something like that, it's a spam. That's how the data set contains. And this does the learning here. And we'll check the model here, and on get model we will order this embedding as the word embedding as 1000 here, and the input length is max length, which I have defined there. And this global max pooling 1D I am using, and dense of 256 neurons I am adding, then dropout of 0.2, then activation I am using as relu. And since the output thing is either spam or ham, dense 1 I have to add. This is the output layer. Then activation of sigmoid I am using for it, then model of summary, and then I'll compile. And since it takes long time, I have kept compiled and kept here. As you can see, the accuracy, it's 0.9989. It's a pretty huge accuracy. And I'll show for RNN, and I'll keep for running, and I'll explain you so it happens simultaneously. What I am doing here is same this thing I am using, and what we can see here is, instead of this I am using this add 20, and instead of CNN model I am using the RNN model here, simple RNN with 32 neurons and one dense layer as output, which I'll be getting. And summary, I am using Adam optimizer, this loss function as binary cross entropy, and accuracy I am getting, as you can see, the accuracy is 96 here. The last time what we got from CNN was 99. Here we are getting 96 accuracy. And this image classification new, what we are doing, instead of CIFAR 10 which we are taken in class, here we are using CIFAR 100. And using CNN convolution 2D we have added 32 3x3 as our filter size, and input shape is here 32 32 and RGB 3, and we have added our layers, the same layers, 64 feature sets, 64, 128 or 128. After adding all this, we have flattened the layer, dropout as we have given 0.2, the dense layer of 1024 we added. After all this, what efficiency, after this the efficiency we are printing here, and it shows the TensorFlow graph also. It's take pretty huge time, but I can say it gave us the good accuracy. And whose screenshot I have put here, I'll show you in my wiki page. CNN comparison, this I have done here. Then later if I come down, TensorFlow graphs of this I have shown. Using this CIFAR 100 I have done it. It's taking a very large time since it's a huge data set. We are using CIFAR 100 here, but I can tell you that we got pretty good accuracy with it. That's it, and thank you.